So in this lecture, we're going to keep looking at these questions, right? And we're going to kind of look at some that are maybe a little more complicated, a little more interesting, right? So here, I have a situation where a person is standing on the dock of a cruise ship, and he wants to know how much higher the ship is. Now, this one, it explains it here. This is a little trickier because you can't get to a spot directly underneath the tallest part of the ship, which we would kind of need to do if we wanted to make a right triangle here. Right, so instead he's going to do this thing. You'll see how the calculations work in a minute. He takes he takes an elevation reading from two different places a fixed distance apart. Right, so here's kind of what this looks like. Right, I'm going to do, let's see, the water line, and over here we have our cruise ship, and then here is the dock. And what this person does is he stands here and he gets an elevation, right? And this is the 84.3 degrees. And then he takes a little walk, right? He goes 10 feet away and he takes another reading, right? He gets a second elevation, right? And this elevation is 82.9 degrees. Okay, so how can we turn these into the height above the dock? Right, well, here's what I'm going to do. I'm going to draw a right triangle. Right, we're still kind of playing off of these right triangles. So I'm going to draw a right triangle here. Okay, now, here's what I'm going to do. Right, I'm going to put some variables in here. I'm going to let this height, this is the distance we're actually looking for. I'm going to let this be y. And I'm going to let this distance be x. Right, so now what do I know? I know the tangent of 84.3 degrees equals y over x. All right, now I want to do the same thing with the other triangle, right? With this big triangle down here. Well, this distance is x plus 10. Right, so that gives me another equation. Now I know the tangent of 82.9 degrees is equal to y over x plus 10. All right, so here's what I'm going to do. Right, let's solve both of these for y. The first equation says that y equals x tangent 84.3 degrees. The second equation says y equals x plus 10 times the tangent of 82.9 degrees. Now, I have a system of equations, right? Two equations, two variables. I'm going to use substitution method. I'm going to take this x tangent 84.3 and substitute it into the other equation for y. This becomes x tangent 84.3 equals the other side. Look, I need to solve this equation now, right? So I'm gonna distribute that tangent into the parentheses. This becomes x tangent 82.9 plus 10 tangent 82.9. Now, move the x term over to the other side. X tangent 84.3 minus x tangent 82.9 equals 10 tangent 82.9. Factor out the x. Factor out the x. This is x tangent 84.3 minus tangent 82.9 equals 10 tangent 82.9. And now divide. Right, divide by this expression here, and we get x equals 10 tangent 82.9 divided by tangent 84.3 minus tangent 82.9. And now you go to your calculator. My calculator says this is 103.8 feet, and that's the answer to my question. Right? Because is it? Oh, wow, it's not. Sorry. That's x, and we were asked to find y. Sorry. X is 40.3 feet. So now to get y, I'm going to take this x value, I'm going to substitute it into here, and I get y is 40.3 tangent 84.3, and that is 103.8 feet. That's the height I was looking for, right? The height of the ship above the dock is 103.8 feet. Okay, so I'm going to let you try this one, right? It's kind of similar, right? See, work on this one, see what you come up with. Okay, so we're doing a similar thing here. We have this, this is actually a thing, right? I went to the University of Florida. Century Tower is this big, Carolyn, it's like a bell tower. Every day, someone goes up into every hour. Someone goes up into the tower. It's got a big thing in it. It's like a keyboard, and they literally play the bells to chime the hour. So what this looks like, right? I've got the ground, and I've got this bell tower. Oh, that's not very good. Sorry, my art skills are pretty limited. Let me try that again. There we go. We've got our bell tower here. And what do I know? I'm doing the same kind of thing, right? I'm going to take a measurement, and I get an angle of elevation of 82.48 degrees. And at this point, he is 20 feet from the tower. Okay, and the observer is holding, whoops, got to move this up. The observer is holding this measuring instrument at eye level. So from eye level, the angle of elevation is 82.48 degrees. And you see, there's my right triangle. Right, so let's see. I'm going to call this x, and what I'm looking for is y. It's this full distance. But what I'm going to do, I'm going to find x, then I'm going to add her height. Right? Add those two values together, and I should get the number that I need. So let's see. What do I know here? I know x and that 20 feet. So tangent 82.48 degrees equals x over 20. X is 20 tangent 82.48 degrees, which my calculator says is 151.5 feet. Then to get y, I'm going to take 151.5 feet and add her 5 foot 10 inches. But I can't do that because I can't mix and match my units. So I'm going to call this 5 feet plus 10 divided by 12 feet, right? I'm converting those 10 inches into feet. And my calculator says this is 157 feet 4 inches. Okay, so we have a new way of defining an angle here, right? It's called a bearing. It's this south 80 degrees east part. All right, so what this is saying, right? We have Miami here. And what this south 80 degrees east is saying is go south, right? Look kind of in the south direction. And then go around 80 degrees in the direction of east. It's almost 90 degrees, right? So it's fairly shallow here. And that is the direction this object is going. So this angle here is 80 degrees. Right, and it's saying at a speed of 17.3 miles per hour, and he maintains this bearing for 1 hour. Right, so after 1 hour, he's going to have gone at that speed 17.3 miles in that direction. Okay. Then what does he do? He turns south. He makes a 90-degree turn. So now he's going this way, and he proceeds at the same speed for 2 hours. All right, well, that means he's gone twice that distance. He's gone 34.6 miles, and that's a right angle. Okay, so what I want to know is, what is his new bearing relative to the port? So let's see. Let me finish my triangle here. All right, there we go. All right, now, what do I need to know? Well, if I can get this angle here, right, then I can get this angle, which is his new bearing, just by subtracting that value from 80. Okay, so let's do that. Let's call this theta. Then the tangent of theta equals 34.6 divided by 17.3, which happens to be 2. And now I can get theta, right? Take the inverse tangent of both sides. The inverse tangent of 2, according to my calculator, is 63.4 degrees. Right, so that's this angle, which means this angle down here is 80 minus that. Well, 80 minus that is 16.6 degrees. Now I can answer my question using this same notation. To get to that bearing line, look to the south and go 16.6 degrees east. That's going to be the new bearing. Okay, I got a bunch of examples under our belt. Right? What are we going to do next? Well, next we've got some more formulas. We've got some formulas to talk about. Two really interesting formulas. They're called the Law of Sines and the Law of Cosines. And what makes these interesting is they apply to any triangle. Right? So far, everything we've done using our trig ratios, we've limited ourselves to just looking at right angles. Well, now we can do more. Right? Turns out we actually can talk about non-right triangles, right? And that's what these formulas are going to do for us.